Jamb 2026 candidates, welcome to the continuation of our chemistry lecture covering the Jamb syllabus for Jamb UTME 2026 preparation. Please get your pen and your notebook, your chemistry notebook, and continue with this lecture. So as we go, continue to jot down what you understand, pause the video momentarily, and jot down what you understand. Today, we are continuing with atomic structure. And what is atomic structure? It's the structure of an atom, okay? The structure of an atom, what an atom comprises of structurally, okay? So, the first concept under the atomic structure is atom, okay? First of all, we have to understand what an atom is. So, atom is the smallest indivisible particle of an element which can take part in a chemical reaction or which retains its chemical properties, as simple as that. And who defined atom like this is Darting, okay? Darting defined atom as the smallest particle of an element that retains its chemical properties, okay? Now, let's look at molecule. What is molecule? Molecule is two or more, atom chemically bonded together, okay? Two or more atoms chemically bound, that's molecule. They are chemically bound and they exist independently. Two or more atoms chemically bound exist independently. For example, all these are examples of molecules. You have hydrogen, that's two hydrogen atoms forming hydrogen molecule. You have carbon 4 oxide, that's two oxygen molecule plus one carbon molecule forming carbon 4 oxide. So it exists independently, it exists on its own, and it comprises of two or more atoms chemically bound together. What is ion? Charged particle formed when atom gain or lose electron. So ion is a particle that possesses an electric charge, okay? It is lost or gained during ionic bond formation, okay? During ionic bonding, during redox process, during redox reaction, ion is either gained or lost. So during ionization, it is either gained or lost. An ion is charged and it can either be identified as positive, which is known as the cation, or as negative, which is known as the anion. Now let's look at the atomic theories. The first atomic theory we are looking at here is, because Jamb says we should master all the atomic theories, the first atomic theory that we are looking at here is the Darting's atomic theory. And what did he propose? Darting proposed atomic theory that matter is made up of what? Atoms. Matter is made up of what? Atoms, and that atoms are indivisible. Atoms are what? Indivisible. Darting. That's what he said. He said matter is made up of what? Atoms. And those atoms are indivisible. They are indivisible particles. Always remember that he was the one that defined atom as indivisible particle of an element. Can you see? Indivisible. Indivisible atom. That is the smallest, cannot be divided. That's what Darting postulated in the atomic theory. So the next we have here is Thomson. Thomson also contributed to the atomic theory, and he discovered electron. Okay. So Darting proposed atomic theory. Okay. But Thomson discovered electron. So it's like Darting was the first person to work on atom, okay? So the rest under him, like Thomson, Rutherford, Millikan, and mostly Bohr, and so on and so forth, they started, capitalizing on his discovery and his postulation, advancing it, okay, discovering more. But he was the foundation. Darting was the foundation. That's why when you talk about atom or atomic theory, you mention Darting first, okay? Because he proposed atomic theory. Then after I proposed atomic theory, Thomson discovered electron. Shortly after who? Shortly after, Thomson discovered electron. And he proposed the plum-pudding model, okay? He discovered electron and proposed the what? The plum-pudding model. So Thomson said that electrons are found inside the what? The atom, okay? That electrons are found what? Inside the atom. Okay, that's the plum-pudding model. Okay, he discovered the electron and said that these electrons are found inside the atoms. Okay, so let's look at Rutherford. Shortly after, Rutherford discovered nuclear model. Okay, nuclear model about the nucleus. And what was the discovery? What did he discover? He discovered that atom has dense nucleus with proton, electrons orbiting around. So he says that the nucleus of an atom is dense and there is proton inside. Okay, there are protons inside and it has electrons orbiting around it. Okay, remember Thomson discovered electron, but he said electron is inside. But Rutherford said the atom has a dense nucleus with proton inside with electrons orbiting around it. Now let's look at what Millikan contributed. Millikan did the oil drop experiment, the famous oil drop experiment, used to measure charge. Okay, so Millikan used the oil drop experiment to measure charge on the electron, or the charge of the electron. Okay, he measured the charge of the electron with the oil drop experiment. Then the next year is Moseley, and Moseley discovered what? Atomic number. He gave it the definition, and he defined atomic number as the identity of elements. According to Moseley, he defined atomic number as what? The identity of elements. The final we have here is Bohr. And what's Bohr's model? Bohr said that electrons occupy quantized energy level. That's the shell. So Bohr said that electron occupy various quantized energy level. That's this one might occupy a higher energy level, this one might occupy a lower energy level, like the shell, KLMNO. The shell, okay, different levels, KLMNO. That's what Bohr postulated, okay, that electron atoms are made of electrons. Yes, that's what he said. But he said that these electrons found around the atom, they occupy various or quantized. You are talking about, when you say quantized, you are talking about quantity, okay, different energy level. Some are higher, some are lower, okay, like the KLMNO here. That's, he's trying to tell you that there are shells, there are levels to this electron arrangement on the orbits of atoms. That's Bohr's model. So you can see that Bohr's model is the most advanced of the three models talking about electron. You know that Thomson discovered electron and he talked about electron, but he said it was inside. Okay, he said electron is inside the atom. Then Rutherford also talked about electron. He said there is proton in the nucleus, but electron orbit around. So Rutherford went ahead to say that electron orbits around the atom. So then this guy now, Bohr now later said that yes, it is true that electron orbits around the what? The atom, but they orbit around it occupying different quantized energy levels. That's different shells. As simple as that, chicken. That's the, I just broke down the atomic theory to you within few minutes. I know that you must have grabbed the complete atomic theory now. Hope you are still making your notes. So now let's look at atomic structure. Okay, the first concept we have under the atomic structure, because Jamb wants us to understand these concepts one after the other. The first we have there is what? Atomic number, and it is represented by the letter Z, capital letter Z. And what is atomic number? The synonym for atomic number is the number of protons. Okay, the number of protons postulated by who? Mostly, okay, but you know Rutherford also talked about proton that is found in the nucleus. Okay, so the number of proton is what? The atomic number. Okay, that's the synonym for atomic number. Jamb can ask you a question, tell you that what is the number of proton of an element, or atomic number is what, or so element, this so element, what is the proton number? They will put atomic number there. If you don't know that it's proton number, that is atomic number, you are going to fail it. So mass number, which is A, okay, capital letter A is the symbol, okay, and what is the synonym of mass number? Mass number is proton plus neutrons, okay, protons plus what? Neutrons. You plus two of them, you get your mass number. Jamb can also ask you questions. They like to do this kind of thing where they always ask questions related to this atomic number and mass number, okay. Then the third concept we have here is isotopes, okay. And what are isotopes? Okay, atoms of the same element with the same atomic number but different mass number. Just know that they are atoms of the same element, the same atom, the same element, having what? The same atomic number but different mass number. Okay, the first we have here, for example, we have carbon. Carbon 12 is having 12 as mass number here. It still maintains the same atomic number. The same carbon here is having 14 as mass number. So all these are what? Isotopes of carbon. Chlorine also have two isotopes, okay? One having 35 and the other one having 37. Two isotopes of chlorine. So you know that the atomic number of carbon is 6. So all these isotopes you see here, they have 6 as atomic number, but the mass number are different. So isotopy is a phenomenon whereby atoms of the same element bear the same atomic number but different mass number. The same atomic number but what? Different mass number, okay? Isotope are what? That particular atom, atoms of the same elements that have the same atomic number and different mass number. Now let's look at quantum numbers. Okay, under quantum numbers, the concept we have here that is very important in preparation for Jamb UTME, as specified and recommended by Jamb syllabus, is the principle. The principle, and the principle, small letter n, means the energy level. That principle is the energy level. Okay, then the azimuthal. The azimuthal, which is capital letter I, is the shape of the orbital. This is in the subshell level. Okay, where you have the SPDF, that's the shape of the orbital. Okay, then the shell level is the KLMNO, that's the shell level. Then the subshell level is the SPDF. This SPDF is what you use in writing out the electronic configuration of elements. Okay, so if you have not taken my lecture on electronic configuration, ensure you go and take my lecture on electronic configuration or electron configuration. So the third concept under quantum numbers is magnetic. That's M, okay, which is the orientation. The orientation means how they are arranged. How many electrons can they accommodate? How many electrons is their maximum? I treated all this when I treated electronic configuration. So ensure you take that lecture, electronic configuration. So the orientation is the amount of electrons that each shell can carry or can hold, the maximum. Okay, that's the orientation, how they are arranged, how these electrons are arranged in these SPDF orbitals or shells. Okay, then the final one here is what? Is the spin. Okay, the spin is what? Like the electron spin, plus half or minus half, depending on the spin. Okay, is it up or is it down? What's the spin like? Is it facing up or is it facing down? But we just have to be familiar with all these concepts. Okay, What this is talking about is electronic configuration. I already treated that topic. I treated that topic explicitly. Okay, so do well to what? Take my lecture on electronic configuration. I also treated the fathers of electronic configuration, the three theorists that develop the principles of electronic configuration, which are Hofbauer and the rest. So ensure to what? Look at it. Now let's look at electronic configuration proper. For you to write out the electronic configuration of our elements, for example, you have to know the atomic number of the elements. That's the first step to finding the electronic configuration, or to writing the electronic configuration of an element. So you have to what? To find the atomic number of the elements. And Jamb specified in the syllabus that you should what? Concentrate on elements 1 to 20. That's first 20 elements. Yeah? No do past that one. Then we'll ask you question past first 20 elements. For example, oxygen. The atomic number of oxygen Z is equal to 8. Okay, remember Z is the symbol for atomic number. So it's 8. That's the atomic number of oxygen. And you follow the sequence following the quantum number, following this process of electronic configuration. Okay, energy level, shape of orbital, orientation, and electron spin. Okay, then you go 1s2. You are, first of all, you are going to draw the diagram. Okay, you are going to draw the shared diagram for electronic configuration. Okay, so after drawing the diagram, writing everything out, 1s, 2s, 3s, 4s, 5s, then you start from 2, 2p, 3p, 4p, 5p, then you start from d, 3d, 4d, and so on and so forth, just like that. Then you use an oblique line to trace the direction of flow. Okay, an oblique line like this. So ensure you take my lecture on electronic configuration. I don't have to be wasting time on this. So for you to know that you use the atomic number to know the electronic configuration of elements, you are going to count all this number here, all these exponents, all this raising power here. Add all of them together, you are going to get the atomic number of these elements. Okay, that's 1s2, 2s2, 2p4. That's this plus this, this plus this. That's 8. So 8 is the atomic number. That's why this is the electronic configuration of oxygen and oxygen alone. So when we look at the orbitals, we have the s orbitals. The s orbital is spherical in shape. The s orbital is what? Spherical in shape. We have the p orbital. The p orbital is what? Dome shell in shape. Okay, it has 3 orientation: px, py, pz, as postulated by the what? The theories of electron configuration. Okay, p orbital has what? 3 orientations: ps, py, pz. Put that for your head though. And it's dumbbell shaped. Okay, while s orbital is what? Spherical in shape. So now all these ones, then Jamb say make we what? Make we what? Master. So Jamb will not set any question for you where you are going to need the d orbital. No. Any electronic configuration that they are giving you, you are never going to use the d orbital. The orientation for the s orbital is 2. Okay, then the orientation for the p orbital, the maximum electron that it can accommodate, is what? 6. Let me just tell you the rest. Okay, the d orbital can accommodate 10, while the f orbital can accommodate 14. Now let's look at the shapes of molecules. Okay, these shapes of simple molecules, Jamb, no, they forget to set them everywhere. So ensure you get conversant with this. Ensure you get used to them. Ensure you learn them completely. Okay, the first we have here are the linear shape molecule. What does linear mean? When we treated physics, I taught you the meaning of linear. When you say something is linear, always use line to remember it. When you say linear, use line to remember. Linear, whatever linear is line, straight. When you say linear is straight, linear momentum on a straight line. Straight molecule on a straight line. So this is a molecule. Remember that atoms form molecule. 2 or more atoms chemically bound together forms what? Molecule. Let's say this hydrogen now that has 2 molecules now, for example, and its shape is linear. Okay, so we are going to have one hydrogen here, another what? Hydrogen here. That's what it means that the shape is linear. Straight line, in a straight line. Both of them are bound in a straight line. Okay, linear. So look at this one, the same thing, all of them. Okay, so hydrogen, oxygen, chlorine, hydrogen chloride. That's hydrogen chloride molecule. Carbon dioxide molecule. All these are linear shape. The shape of their molecules are linear. Okay, so the next we have here is non-linear. That's bent shape. If something is not straight, non-linear, meaning it's bent. So the bent shape ones is water. For example, the most common is water. The inside your head. Then tetrahedral shape is what? Methane. Methane is a very common gas. Okay, with the tetrahedral shape. Okay, when you say tetrahedral, it means that what is the meaning of tetra? Tetra is 4. Okay, hedral means that it has 4 sides. Okay, 4 sides. Okay, so tetra. So it shows that you have carbon in the middle, then you have hydrogen up, hydrogen down, hydrogen right, hydrogen left. That's the shape of the molecule. So when you connect it, it's going to give you a tetrahedral shape. Okay, tetrahedral shape, 4-sided, 1, 2, 3, 4, just like a kite. Now let's look at the pyramidal. Okay, the pyramidal and shape molecule is ammonia. That's what we have here. Ammonia has the pyramidal shape molecule. So I want to give you an assignment right here. Write it down in your notes so that after the lecture you look for it. Go and look for the molecular shape of graphite and diamond. Put it inside your head. Okay, so go and look for the shape of what? The molecular shape of graphite and what? Diamond. And also understand the crystalline arrangement in diamonds. All right, now that we have understood the atomic theory, let's quickly take some Jamb must repeat questions to further test the knowledge we've acquired so far. Jamb must repeat questions. Question 94. An atom has atomic number 17 and mass number 35. How many neutrons are present? A. 17, B. 18, C. 15, D. 52. This is a technical question. From what I just taught you, use it to calculate the neutron number. Remember what atomic number is, okay? So if you know atomic number, how are you going to get the neutron number? This is mass number, and you know mass number. Since you know the formula for mass number, you know what atomic number is. It's easy to get the what? The neutron number. Let's go. Question 95. Which of the following pairs are isotopes? A. The one of carbon and nitrogen, carbon 12 and carbon 13, hydrogen 1 and helium 2, oxygen 16 and sulfur 16. What's the answer? Drop the answer in the comment section. Question 96. Who proposed that the atomic number defines the identity of an element? A. Dalton, B. Rutherford, C. Moseley, D. Bohr. What's the answer? Drop the answer in the comment section. Question 97. The electron configuration of oxygen Z equal to 8. That's atomic number equal to 8 is what? A. That's the option. B. That's the option. C. That's the option. D. That's the option. What's the answer? Drop the answer in the comment section. Question 98. Which of the following increases across a period from left to right? Remember, I've already made a lecture on periodic table. So which of these increase from left to right? If you haven't accessed my lecture on periodic table and periodicity, do well to check the playlist and access the lecture. A. Atomic radius. B. Ionization energy. C. Metallic character. D. Electropositivity. What's the answer? Drop the answer in the comment section. Question 99. Which of the following compounds contain a coordinate bond? A. Sodium chloride. B. Ammonia ion. C. Water. D. Methane. What's the answer? Drop the answer in the comment section. Question 100. Which of the following molecules is tetrahedral in shape? A. Water. B. Ammonia. C. Methane. D. Carbon 4 oxide. What's the answer? Drop the answer in the comment section. Question 101. Van der Waals forces are best described as A. Strong ionic bonds. B. Weak intermolecular force. C. Metallic bonds. D. Covalent bonds. What's the answer? Drop the answer in the comment section. Do you know that I can actually force you to pass your Jamb UTME? So do well to get this my concise lecture. This lecture material you are seeing here on the screen is just the same way I have it in my library. Do well to access my library. A lot of students are taking action. A lot of students are blasting it. A lot of students are getting it clear. So what are you waiting for? Access this library with just a token 1K. Send me a DM. Phone number in my bio. Allow me force you to pass this Jamb. Trust me, it is very short, concise, colorful, and interesting to read, covering the whole Jamb UTME 2026 syllabus. Jamb 2026 candidate. Peace out.